All right, let's get going here. Let's see how this one goes. First, I'm going to do the problem there. I gave you a square inscribed in another square, and I asked you what would the shaded area be, and I'm going to solve that problem now. There are different ways to do it, but I'll just do it the way I see it right at this moment. There are actually quite a few ways to do it. So let's remake the figure, just a square. You're always forgiving my art skills, of course. And there's another square inscribed. So both are squares, even if they don't quite look like it when I'm writing it up here. And again, the idea is to find the shaded area and then to figure out what percent the shaded area takes, given that the square is 1. Okay? Well, if the square is 1, and I put a square in here, then by definition, half of 1 is 1/2. So this side is 1/2. And by the same reasoning, the other side is 1/2. So let's see how these these radicals pop up, and how they enable us to do the simplest problems. I'll extract one of these guys here. They're all symmetrical and congruent. And here we go. We have legs of 1/2 and 1/2. And if I can figure out this guy right here, well, that's one of the sides of the square. Well, I should be done there. You'll be able to follow my reasoning right now. So here we go again. A squared. Obviously, there's a right triangle here. Okay, as you see. Just trying to cover all my bases here. A squared plus b squared equals c squared. And this time we're looking for the hypotenuse. And that would be the side of the square that's been inscribed. So I have 1/2 squared plus 1/2 squared. And we'll call this x, just for the sake of argument, x squared. And that would mean that 1/4 plus 1/4, because if you're not seeing that, 1/2 times 1/2 is 1/4, just in case some of the weaker students aren't seeing that, equals x squared. And now I continue, but 1/4 plus 1/4 is 2/4. 2/4, as you know, equals 1/2 equals x squared. So then when I put the hat on both sides, I get 1 over radical 2. Now, that's something we're going to talk about. I'll do the video tomorrow, so we don't, put too much work down in one place. But this is not simplified. I'll talk about that some other time. But we do have, right here, a side for x. Okay? So now, when I put everything together here, I'm going to square it, and so I'm going to have the one side of the square equals x equals 1 over radical 2. Now I'm going to square it because that would be the side, and there we go. X squared all over again because I'm calculating the area. Excuse me, that's not coronavirus, by the way. Equals area. Okay, can you still see it? I'm checking here. Yeah, I'm just on the borders there. And that means that 1 times 1 over radical 2 equals 1/2. Oh, isn't that something? Wow. So that means that this is 1/2, right? And this is 1, and 1 minus 1/2 is 1/2. So if we do the math, 50% is unoccupied, because 1 squared minus the 1/2 that I just occupied is 50%. And there you could easily do it, figure out these kind of problems using the radicals. Okay, and I'll talk about this at another time. This needs some work. We don't care right now. We got the answer that we were looking for. All right, continuing. and erasing all the stuff that's getting in our way, we want to find what the empty space is in both of these shapes. So I'm not a good artist, but most kids who are serious understand what I'm doing. I fit the sphere snugly in here, and I fit the cylinder snugly in here. And if you're shipping containers or something like that, which would be more economical to ship? Obviously, the most economical way to ship containers, or crates, we could call these crates if we like, right? Would be to minimize extra space. Of course, that makes sense. So anyway, it's a basic idea in math and in engineering. And so what we'll do now is we'll calculate the top one and we'll calculate the bottom one. And you might be a little surprised at what I come up with. I'm going to cheat like I did yesterday. I'm going to say that 3.14, which of course is pi rounded to the 100th, is just 3. Cheating, or whatever you want to call it, or rounding to a whole number, because the ideas will be clear. If you need to know precision, we talked about that so much, then of course we'll get out our calculators, which we did a little earlier. So let's see. How could we fit a sphere with a radius of 1 snugly into a crate? Well, if I draw a little thing here, this is 1, this is 1. So it's got to be 2. If you look at it carefully, 2 units, 2 units, 2 units will snugly fit this object, this sphere, snugly. So I guess if you shook it, it wouldn't move. And that's the thing that we have. So immediately we have that the crate must be, I'll write it over here, the crate must be 2 cubed. And that's a cube, okay? And we took a side or an edge, that's what really I should properly say, and I came up with 2 cubed. So now I have to figure out what's the difference between the crate and the sphere, given that the sphere is 1. So let's do it. Get over here on this side again, sorry about that. And we have 2 cubed minus 4 over 3 pi 1 squared. That's right, guys. You saw that, right? Okay? So let's see. 2 cubed is 8, as you should know at least. And I'm cheating here. I really shouldn't, but I can't resist. 1 squared is 1, and we get 8 minus 4. Oh my God, the space there is 4 cubic units, and it doesn't take a genius in math to see that when we turn it into a ratio, it's only 1/2 full, approximately. A little more, because you got that 0.14 there that will lift it up a little bit, and incredibly, it's around 50% full. Not very efficient to ship something that way. Let's see if cylinders don't do better. By the way, these are problems that they propose to kids these days. Okay? So I'll keep this guy here. I'll use the words crate, and I'll erase all this stuff here. Okay? And now I'm going to compare. So this is only 50% full, or if you like, 50% empty, and we cheated a little, but it might be 51, 52%. Not a good percent if you're a shipper, if you're shipping things in crates. Now here, I had to have the height as 2, so I can have the cube again, because if the radius is 1, that makes this 2. So for it to fit snugly inside this guy, where everything's touching, it would have to be a radius of 1 and a height of 2. I mean, that's the way they would package it. So we already did the math for the crate. The crate is 2 times 2 times 2. That's the length, the width, the height. That's 2/3. And that, of course, equals 8. We don't need to repeat that constantly. So let's see. We have 2 cubed minus, and now we have the data here. We have to be a little careful. It's a cylinder, or maybe a barrel of oil or something like that, right? A barrel of oil or whatever you can think of here, times pi 1 squared times 2. Oh, okay. So I look at that. Again, I'm cheating. I know, but there's nothing really gained by getting the decimals in there. It's all conceptual. And now I have 8 minus 6. Oh, so that equals 2 cubic units of empty space. But more revealing is 6 over 8 reduces to 3 over 4. Let's see if I'm still fitting here. Equals to 0.75. And oh my God, much better than spheres. 75% is occupied and only 25% is empty. Oh, so now we see why when people ship things like oil, just to throw out something that people ship all the time, they use barrels instead of spheres. And immediately, if you did a little bit of simple math here, you could see why. And that's what I was doing yesterday. Okay, I'm going to stop it here now. Tomorrow we're going to talk about all sorts of different things, but simplifying radicals will be on the top of the agenda. Okay.